Sorry for the abrupt break in between. Actually, there was some problem with the recording device, and therefore I had to restart the whole thing. Sorry for the interruption. And currently, as you can see that the robot, I have started another execution, and after training, the robot is going through and executing the plan. And in this plan, it is taking the directions according to the Q values. For each state, it is just picking the highest Q value, because I have set now the epsilon to be 0 because it's in the testing phase, so it's just exploiting whatever it has learned. And the best thing about this is that because it starts from random locations, and also because the exploration rate is very high, now that I started from a different start location, but given a fixed goal state, it can still track the optimal path and follow the optimal policy. And now we see the agent moving from top, the start state, which has changed to 0, 0 from 9, 0. And here we see that the optimal policy was to go down, and it goes down. Here it takes a right, and it is continuously following the policy. And as I had mentioned, that the robot can be thought of just a single pixel, which is at the center of the simulation. But the simulation is bounded by 60 pixels, so it cannot go into the walls. And so whenever it enters a waypoint, no matter how small, you can see a change and it following the optimal policy. So, and also the stochasticity of the environment can be seen. If we look carefully, there are certain zigzag patterns around which show the stochasticity of the robot. And again, we see the robot following the optimal policy again and again. And an interesting thing I would like to point out is in this square, because it cannot go up or down, up and down remain 0 because they have never been explored. So this is a very nice thing. Though here we do see certain values of down, because when the robot just enters this place, sometimes it might happen that it can take a down value because of the stochastic nature of the environment. It might not have entered it properly, and down was still a valid place to go. So, but in this cell, which is a very interesting one, we can see that because there's simply no other way the robot can enter the cell, so this whole path is mapped out in that way. And here we don't see any change because the other stochastic nature of the system, it cannot make it go up or down, just make it go left. So the line here in this complete direction remains straight. And this is when the robot reaches the end of the goal, and this is the complete demonstration for Q-learning, uh, which completes our entire demonstration of both A-star and Q-learning and how the grid world works. Thank you for watching the demonstration.